Hi, you guys. We've got a really important and exciting vocab word to talk about today, and that vocab word is critical points. So I want to remind you of the roller coaster example. Remember, we have a roller coaster that looks something like this, and we've talked a lot about what horizontal tangent means. It means when the roller coaster is flat or when it goes from increasing to decreasing or decreasing to increasing. We have a horizontal tangent right here and right here. At those x values, those specific x values where the roller coaster changes or is flat, that is called a critical point. Okay, so remember some stuff for you to copy down. You know, when the derivative is positive, that means the roller coaster is going up. This is a positive derivative here because it means positive slope. Zero slope, negative slope, so negative derivative. Zero slope again, positive slope, so positive derivative. That's what that means. When the roller coaster is traveling along the original function, remember, which is f of x, the derivative is f of x, or f prime of x. So make sure you're paying really close attention to the notation. That's a very, very small detail right there, that prime symbol, the apostrophe, but that's super important. So critical number, the new vocab word, it's the x value where the derivative equals 0, where there's a horizontal tangent. So let's talk about this example here. Again, some more things for you to copy down. What we have is, where is the critical number or numbers? In this case, the roller coaster is increasing, going up, going up, going up, and then it is flat, and then it starts going down. So right here at this x value of 1, notice I wrote x equals 1, that's a critical value. We have another one right here because it starts from going down to up. So critical value right there, that x value is 2. Where is it increasing and where is it decreasing? These are intervals like what we had on the quiz. It's increasing from here to here. I'm assuming there's an arrow here that it's continuing down forever, so that's why I put negative infinity to 1. Remember, you always use the x value as the endpoints, and for increasing, decreasing intervals, we always use parentheses. And it's decreasing between 1 and 2. The x value is between 1 and 2. That's where the roller coaster is going down. Increasing again from 2 to infinity. Again, I'm assuming that there's an arrow here. It continues on forever. So we talked a little bit in class today about relative min and relative max. And so when we have a top of a hump, that's called a maximum, and it's a relative maximum point. And be really careful here because I'm asking for the specific point, so that means x comma y. So I have a maximum here, this blue dot at 1, 2. So that's why I wrote the point there. I have a bottom of a hump right here, which is referred to as a minimum because it's going from down to up. So we have a minimum value right here at the x value of 2. The point is 2, 1. Okay, so make sure that you're giving, if it's asking for values, it's asking for y values. That means how high or how low. High and low are y values on the coordinate plane. So make sure that you're paying very specific, close attention to whether it's asking for a point, that means give me an ordered pair, or the actual value, which is the y value, which is right here, the 2 or the 1, and not to be confused with the critical number, which is x values, okay? So make sure that you're answering the correct question that I ask. Let's do a little bit of practice. Moving on, we are going to label the extrema and indicate where the functions increase and decrease. So this very first example, you can see the roller coaster is very boring. It has one top of the hump right here, which looks like the ordered pair 2, 10. So that is referred to as a maximum, okay? It's a maximum because it is a top of a hump, so it's the highest part of the roller coaster. And that means that I have two different intervals. I have one for increasing, and I have one for decreasing. It appears as though it is increasing right here on the roller coaster, the left-hand side of the parabola. So that would be negative infinity up until the x value here, which is 2. So negative infinity to 2. I always put parentheses on increasing and decreasing functions. It is decreasing starting at 2, and then the roller coaster starts to decrease and everyone starts to plummet to their death. I hate roller coasters, you guys know that. Anyways, it's decreasing from 2 to the right forever. So make sure that you're always using x values on intervals. Make a little note about that, okay? Let's try another one. Let's go over here. Ooh, a little bit more of an exciting roller coaster. Looks like I have two different minimums right here. So I have a minimum at, what is that ordered pair? -2, comma, -6. And another minimum at 2, comma, -6. There's two bottoms of the humps there. I have a maximum up here, which looks like 0, comma, 10. So this should be like very simple. You should be hopefully a little bit bored right now, but not too bored. We have two intervals where it's decreasing. So the roller coaster is going down right here, which would be -infinity to -2. Remember, we always use the x value. So decreasing -infinity to -2. And there's another spot where it's decreasing. Where is that? This part. 0 to +2. Remember, always x values. So 0 to 2. And where is it increasing? The opposite, or the other spots. So increasing right here between -2 and 0, and also between 2 and infinity. That's where the roller coaster is going up. So -2 to 0 and 2 to infinity. Yeah, these should go together unless there's a flat section of the roller coaster, like the beginning or the end, most likely on an actual roller coaster. The opposite of the decreasing should be the increasing. So like, see how there's a gap here between -2 and 0? That's because it's increasing there. There's also a gap between 2 and infinity, and that's because it's increasing there. So just keep that in mind, that those increasing, decreasing intervals should go together. Pause the video, try number 3 and number 4. I will fill them out, and then we'll come back. So here's what I got for this, you guys. I'll zoom in on this first one. It appears as though I have a maximum right here. That ordered pair is 0, 2. I have a minimum right here. That ordered pair is 2, -2. Increasing in two places right here, which is -infinity to 0. Make sure you always use the x value in your intervals for increasing and decreasing. And also it starts increasing again here at the x value of 2 up forever, so 2 to infinity. The only decreasing section is right here, and those x values are 0 to 2. Very similar from doing like domain. That's kind of the same way that you're setting up the intervals, just if that's reminding you of anything. Let's look at number 4. I got a lot going on in number 4. This looks like a super fun roller coaster. The maximum values, I have one here and I have one here. Those ordered pairs are -3, 2 and 2, 1. I have two different minimums, this one and this one. So -1, -3, and 4, -1. And then increasing, decreasing intervals, there's a lot of turns on this roller coaster. There's a lot of critical points. FYI, these red dots here are called critical points, where the roller coaster is flat, about ready to change direction. Increasing, 3 different sections. This one, that interval is -infinity to -3. This interval between -1 and 2, remember the x values are how we do that. And then the last increasing spot is from 4 to infinity. 3 different decreasing spots. 2 different decreasing spots. This one, so -3 to -1, and this one, 2 to 4. Okay. Now let's do some actual calculus problems. Use the first derivative test to answer the following questions about the function. Letter A says find the derivative, so we're going to do that with our symbol of f prime of x. Let's do 2x plus 8. You should know how to do that very quickly. Bring the 2 down, decrease the exponent by 1, so I'm not even going to put the 1 exponent right there. Derivative of 8x is just 8 because it has a 1 exponent, so the 1 times the 8 is the 8, and then it becomes x to the 0, which makes the x go away altogether. There, my friends, is the derivative. Find the intervals of increase and decrease using the first derivative test. Okay, what this means is you need to set the derivative equal to 0 and solve. That helps you find the critical points. I need to know where this roller coaster is flat. So first thing I'm going to do is I'm going to set my derivative, which is 2x plus 8 equal to 0. That gives me x equals -4, and that is my critical value on the roller coaster where this roller coaster goes from one direction to the other. It is flat, about to change direction. And here's how you set this up. I'm going to put that answer on this number line. This is very exciting, and you are totally going to use this in calculus. So put the answer on the number line. What I'm also going to do is I'm going to write f prime of x here And above it, I'm going to write f of x. So remember that f prime of x is the derivative. And this is the original function, the OG, if you will. Okay. So now what I want to do is I'm going to take a number in this section of the number line, so like -5 or -6 or -100, negative something. And I'm going to plug that number, whatever number I pick in this section of the number line, I'm going to pick -5, plug it into the derivative. So where is my derivative equation? Oh yeah, that was this. When I plug in -5 right here or here, same thing, do you get a positive or a negative number when you plug in -5 right there? You get a negative number, right? I'm just going to put a negative here. Now I'm going to pick a number right here, anywhere on this part of the number line. So I'll pick -3. You could also pick 100 or 17 or whatever number is right here on the number line, any number that is bigger than -4. I'm picking -3. When you plug it in right here, do you get a positive or a negative number? You get a positive number, because if I plug -3 in here, that would be -6 plus 8, which is 2. It's a positive number. We don't care what the number is. I just want to know if it's positive or negative. Okay, so now let's remember what we know about derivatives. If the derivative is negative, doesn't that mean that the original function is decreasing right there? Because if the derivative is negative, that means negative slope. That means the roller coaster is going down. So then how about this? What if the derivative is positive? Derivative is positive, that means my roller coaster is going up. So that means that this value is a minimum. That's because the roller coaster goes from down to up. That makes that point a minimum, okay? So find the maximums and minimums of the function using the first derivative test. Okay, so I wrote a bunch of stuff here. What I wrote is that x equals -4, the graph is a minimum. I wrote that right here. And that's just because the derivative goes from negative to positive, which means the original function goes from decreasing to increasing. That means the roller coaster goes from down to up. That makes it a minimum. How do I figure out what the actual point of the minimum value is? I plug in -4 to the original function. That gives you -11. Okay, so just make sure that you've got down, in order to find the actual point, use the original function, not the f prime. The reason for that is because what happens, just do it in your head, if you take this -4 and plug it into the derivative. You get 0, right? Like, duh, that's because the slope there is 0. Okay, so you have to plug into the original function in order to figure out what the minimum actual point is. The reason why that I didn't answer the question about maximums is because when I solved the equation, the derivative equaling 0, I only got one answer. When you do the derivative down here, which we'll do in class tomorrow, you end up with more than one answers. That means that maybe one of them is a minimum, one of them is a maximum. In this case, we only had one area where the derivative changed from negative to positive, so therefore we only have a minimum. But it is possible to have a maximum and a minimum if you get more than one answer when you solve this equation. We will do that in class tomorrow. Okay, you guys, thanks for watching. Have a great night. Hey, year's almost over, chapter's almost over. You guys are almost done, and you're awesome. Talk to you tomorrow.